In the following videos, we will introduce two new functions, the logarithmic functions and the exponential function. Let's start with the logarithmic function. So for a positive number a, we define the log a of x as the number such that a to that number, in this case y, is equal to x. We will see some examples to clarify this definition. So the domain of this function is all the positive numbers, and we call the number a the basis of the logarithmic function. A very special case and a very important one will be if a is equal to the number e, which is approximately 2.718. In this case, we call log base e of x, we call it ln of x, which is also called the natural logarithm. Let's calculate some examples. So remember that we have the relation log a of x is equal y if a to the y is equal to x. So let's put the definition in action for this example. So the first question is, what is the logarithm with base 2 of 16? So in this case, a is equal to 2 and x is equal to 16. So we have to answer the question, what number y, 2 to the y, is equal to 16? And the answer of this question will give us the logarithm. So in this case, we can calculate that this y is equal to 4. So in this case, we say that this logarithm is equal to 4. Let's see the second example. So in the second example, we need to find the logarithm with base 3 of 9. So in this case, a is equal to 3 and x is equal to 9. So we have to find which y, 3 to the power y, it's equal to 9. From this, we obtain that y is equal to 2. 3 squared is equal to 9. So remember, this is the number that we put in there. So the answer for our question is y is equal to 2. Let's look at the graph of the function. So this will be the graph y equals the natural logarithm of x. And for simplicity, we will almost always use the natural logarithm. We will see why in a few slides. So the most important thing to notice here is that the function is defined for all the positive numbers. The function at 1 is equal to 0. So we say that the natural logarithm of 1 is equal to 0. That corresponds to this point here. Before 1, the function is negative, and after 1, the function is positive. Now let's focus on the derivative of this function. So here we have the derivative of the natural logarithm. So if f is my natural logarithm, then the derivative is just 1 over x. So this is a pretty simple derivative. So let's use it in some examples using the rules we already have and using this new derivative. So let's start finding the derivative of this function. So it's x squared plus 4 times the natural logarithm. So here we can use the sum rule first to obtain that this is 2x plus 4 times the derivative of the natural logarithm. And now that we know that the derivative of the natural logarithm is just 1 over x, we can complete this problem, because this will be equal to 2x plus 4 times 1 over x. And that is our derivative. Let's see this second example now. For this case, we have to use the product rule. So we will have that this is x cubed times the derivative of the natural logarithm plus 3x squared times the natural logarithm. And this is simply equal to x cubed times 1 over x plus 3x squared times the natural logarithm, which we can even simplify as x squared plus 3x squared the natural logarithm.